What is a permutation? Permutation refers to the different possible arrangements of elements in a given set. The permutation of n objects taken R at a time is denoted by these forms, where n is the total number of objects in the set and R is the number of choosing objects from the set. The number of permutations can be found using the permutation formula or the fundamental counting principle. For permutation formula, the number of permutations of a set of n objects taken R at a time is given by the permutation of n secant R is equal to n factorial over the quantity of n minus R factorial, where n is greater than R. And the number of permutations of a set of n objects taken n at a time is given by the permutation of n secant n is equal to n factorial. Now, let's have the fundamental counting principle or the FCP. The fundamental counting principle is a tool that you can use to quickly count the number of ways certain things can happen. FCP states that the product of the numbers is the number of possible arrangements. The fundamental counting principle can be expressed as a three-step process. First, determine the number of decisions. Second, for each decision, determine the number of options. And last, multiply these numbers together to determine the number of possible outcomes. Now, let's have problem number 1. Given a set of 7 different books, how many different arrangements of 4 books are possible? Let's have our first way using the permutation formula. Let's identify first the values of n and r in the given problem. There are 7 objects and they are selected 4 at a time. So the value of n is 7 and the value of r is 4. So now let's use the formula of permutation. We have the permutation of n secant r is equal to n factorial over the quantity of n minus r factorial. Next, let's substitute the values of n and r in the formula. So we have now the permutation of 7 taken 4 is equal to 7 factorial over the quantity of 7 minus 4 factorial. Then, simplify. 7 minus 4 factorial is 3 factorial. So we have now 7 factorial over 3 factorial. Now, let's expand and divide out common factors. Let's expand the factorial up to the factorial that is the same with the factorial in the denominator. As you can see, the factorial in the denominator is 3 factorial. So let's expand 7 factorial to 3 factorial in the numerator. Then let's divide out the common factors in the numerator and the denominator. So the greatest common factor is 3 factorial. So let's divide them out. Then let's simplify further. So 7 times 6 times 5 times 4 is 840. So the permutation of 7 taken 4 is 840. So there are 840 possible different arrangements. Now, let's have our second way using the fundamental counting principle or the FCP. Let's apply the steps of the FCP to find the number of permutations. So first, let's determine the number of decisions. In the given problem, there are 4 decisions or positions to be filled in. Second, for each decision, let's determine the number of options. So for the first decision, there are 7 options. For the second decision, there are 6 options. For the third decision, there are 5 options. And for the fourth decision, there are 4 options. And last, let's multiply the numbers together to determine the number of possible outcomes. So we have 7 times 6 times 5 times 4 is equal to 840. Therefore, there are 840 possible different arrangements. Now, let's compare this answer to our answer in the first way. As you can see, the answers are just the same. So which do you prefer now? So it's up to you which way you are going to use as long as your answer is correct. To know if your answer is correct, let's use these software applications. We have Scientific Calculator and also the Permutation Combination Calculator. Now, Let's use first the scientific calculator.
In this scientific calculator, first you press 7, second you press Shift, third you press NPR since NPR is in the second function, fourth you press 4, and last press the equal sign. Then we have now the answer. So our answer here is 840, and our answer a while ago is also 840. Therefore, our answer is correct. Now, let's have our second software application. Here in Permutation Combination Calculator, all we need to do is just input the values of n and r. Then automatically we will have the answer. So let's now input the value of n, which is 7, and the value of r, which is 4. As you can see, we got the answer automatically. So we have here the answers for permutation and also for combination. So our answer here is 840. Again, our answer a while ago in problem number 1 is 840. Therefore, our answer is correct.
Now, let's have problem number 2. 5 students will be chosen from a group of 15 to be the president, vice president, secretary, treasurer, and auditor of the class. In how many ways can this be done? Let's have our first way using the permutation formula. Again, let's identify first the values of n and r in the given problem. There are 15 objects and they are selected 5 at a time. So the value of n is 15 and the value of r is 5. Now let's use the formula of permutation. So the permutation of n taken r is equal to n factorial over the quantity of n minus r factorial. Next, let's substitute the values of n and r in the formula. So we have now the permutation of 15 taken 5 is equal to 15 factorial over the quantity of 15 minus 5 factorial. Then, let's simplify. So we have 15 minus 5 factorial is 10 factorial. So we have now 15 factorial over 10 factorial. Now, let's expand the factorial up to the factorial that is the same with the factorial in the denominator. As you can see, the factorial in the denominator is 10 factorial. So let's expand 15 factorial to 10 factorial in the numerator. Then let's divide out the common factors in the numerator and in the denominator. So the greatest common factor is 10 factorial. So let's divide them out. Then let's simplify further. So we have now 15 times 14 times 13 times 12 times 11. The answer is 360,360. So the permutation of 15 taken 5 is equal to 360,360. Therefore, there are 360,360 ways. Now, let's have our second way using the fundamental counting principle. Since in a given problem, they are selected 5 at a time, so there are 5 decisions or positions to be filled in. Next, let's identify the number of options for each decision. So for the first decision, there are 15 options. For the second decision, there are 14 options. For the third decision, there are 13 options. For the fourth decision, there are 12 options. And for the fifth decision, there are 11 options. Then, let's multiply the numbers together. So 15 times 14 times 13 times 12 times 11 is equal to 360,360. Therefore, there are 360,360 ways.
Now, try to check in your scientific calculator or in your permutation combination calculator if our answer is correct. Now let's have distinguishable permutation. When you say distinguishable permutation, it refers to the permutations of a set of objects where some of them are alike. The number of distinguishable permutations of n objects when p objects are alike, q objects are alike, r objects are alike, and so on is given by this formula. We have here the steps in solving problems involving distinguishable permutation. First, identify the objects to be arranged. Second, identify the number of objects. Third, Determine the objects that are alike. And last, solve the distinguishable permutation by using the formula distinguishable permutation is equal to n factorial over p factorial, q factorial, r factorial, and so on. Now, let's have problem number 3. Find the number of permutations of the letters of the word alcohol. Now, let's apply the steps of distinguishable permutation. First, the objects to be arranged are the letters of the word alcohol. Second, there are 7 letters in the word alcohol, so our n is equal to 7. Third, there are 2 of L and 2 of O, so we have our P is equal to 2 and our Q is equal to 2. And last, let's apply the distinguishable permutation formula. So we have P is equal to n factorial over P factorial, Q factorial, R factorial, and so on. And let's substitute the values of the variables. So our n is 7, our P is 2, our Q is 2. So we have now P is equal to 7 factorial over 2 factorial, 2 factorial. Let's simplify. 7 factorial is 5040. 2 factorial is 2. 2 factorial is 2. Then, let's simplify further. So we have 2 times 2 is equal to 4. So we have now 5040 over 4. Let's divide. The answer is 1260. Therefore, there are 1260 distinguishable permutations. And last, we have the circular permutation. Circular permutation refers to the different possible arrangements of objects in a circle. The number of possible arrangements of objects in a circle can be solved by using the formula P is equal to the quantity of n minus 1 factorial. Now, let's have problem number 4. Find the number of different ways that a family of 6 can be seated around a circular table. Now, in the given problem, let's identify the value of n, which is the total number of objects. Since there are 6 objects, so the value of n is equal to 6. Now let's apply the value of n to the circular permutation formula. So we have P is equal to the quantity of n minus 1 factorial. Let's substitute the value of n. So we have the quantity of 6 minus 1 factorial. 6 minus 1 is equal to 5. So we have now 5 factorial. And 5 factorial is 120. So therefore, there are 120 different ways.